if you could pull up the slides. I want to thank everyone for coming to our webinar this month. We have a great speaker tonight who is going to, okay, thanks. We have a great speaker tonight who I will introduce you to in a couple minutes, but first I just want to, I have a couple program announcements. First, on the next slide, these are a list of resources that are available to all Penn State students. They put it together after all of the natural disasters that we've had, but they are things like counseling and psychology services and crisis lines that are available not just in times of natural disasters. I put this list on our LinkedIn page, so it's available there. I'm going to keep this slide in this slide deck, so when I post the recording from tonight, it's all going to be available there. And I also have this information, so if you need it and you can't find it anywhere else, you can email me, you can email Rachel, and we will definitely get it to you. There's also specifically about natural disasters, the last bullet is talking about a webinar that's going to be held for World Campus students at the end of this month. And if you're interested in that, we will be sending more details out closer to the 29th. But if there's something specific that you're looking for before we release the information, feel free, again, to get in touch with me or Rachel, and we will make sure that you have all of the information that you need. Secondly, just looking ahead, I know things are going to start to get busy with the holidays, but we have our next two webinars coming up. They're both, again, going to be the first Wednesday of the month at 8 o'clock. In December, we are going to have Charlotte Roy, who is an emergency management coordinator at Newton Wellesley Hospital. She did a lot with the Boston Marathon bombing a few years ago. But Charlotte is a graduate of our program. She is a great, great resource, and we are very excited that she is still a part of our program. And she is a TA in PHP 530. So some of you might know Charlotte, and if not, you will get to meet her in a couple semesters. And then in February, we are going to have, I know him as Chief John Thaler because he is in the Coast Guard Reserve, but he is also Corporal John Thaler with the Rockville Police Department. And he is a wellness advocate for first responders and law enforcement officers. He does a lot with bringing awareness to first responder mental health issues, first responder suicide prevention, and he has done seminars all over the country bringing awareness to this, teaching first responders and law enforcement officers where they can go to get help and the different resources that are available. And this is something that he is very passionate about and is a great resource. So that is going to be another great webinar that we are looking forward to. So I mentioned that I met John through the Coast Guard, and that is also how I met tonight's speaker. I knew him as Commander Chris Lund before he retired. He was an engineering and logistics officer with the Coast Guard, and he is a Coast Guard Academy grad. And he is currently the Assistant Director of Public Works up in Groton, Connecticut, and he manages the Groton Wastewater Treatment Plant, as well as being the Vice President of the Connecticut Water Pollution Abatement Association. He got his bachelor's from the Coast Guard Academy, got a master's in engineering from Oregon State University, and his MPA from Norwich. And right now he is at Johnson & Wales completing his doctorate in educational leadership. So I asked him to come speak tonight. In 410, I have a lot of students that when we talk about Katrina and Sandy, we talk a lot about clean water and water infrastructure and how that is a very important part of public health. But we really never talk about what that means from the big picture. So I asked Chris to come and fill in that gap and talk about the intersections between the water infrastructure, public health, and homeland security. So thank you so much for coming and speaking with us tonight, and I will turn it over to you.
Thanks, Jen. Can you hear me? Just wave or something. Make sure.
Yes, we can hear you.
Okay, so good evening, everyone. Jen was nice enough to give me an introduction, and of course, as Jen mentioned, we used to serve together. Actually, I brought her on active duty orders for some time, and it was one of the best decisions I probably ever made in my Coast Guard career to have her working for us. So she was definitely a great asset for us. So she did ask me to come and talk about a part of my job, which in Groton Public Works, I manage most of the environmental stuff, special projects, and spend a lot of my time at the water pollution control facility, which is one of many terms that are in use now for basically your sewer treatment plant. You may hear clean water plant, you may have WPCF, but most people still think of it as a sewer treatment plant. Now, the one good part about working at the treatment plant is I get to tell people my job stinks and nobody thinks anything of it, as well as my kids like to always know when I get home each night, you know, that I'm pooped from a day at work. So not a lot of humor that you can have, but there's some that we use. So why are we talking about this? Other than being invited to do so, what we're going to cover tonight just briefly is some basics about collection and treatment of wastewater. Most of it's underground, so nobody really knows what's going on until they hear problems occurred. As far as what I understand from the class and the students that are attending the webinar tonight, there's an intersection here between HSPD 7, the critical infrastructure that we're all familiar with. Mostly when we talk about the water side of things, everybody turns immediately to the drinking water side, obviously protection of that resource. But wastewater as well is one of those infrastructures, and since they're so closely connected, you really can't have one without the other. So we're going to talk about that. And also from a public health perspective, you know, it's funny in this day and age, I can ask people, you know, who knows Jon Snow? And of course, the immediate answer is, well, Game of Thrones, of course. Whereas from a public health perspective, Jon Snow was one of the people in Britain in the 1840s that was able to identify the source of the cholera outbreak as a well that was contaminated. So there's an intersection there as well between public health and the homeland security aspects of things. So just to give you an idea of where I'm speaking from tonight, I'm here in Westerly, Rhode Island, and where the little red Google arrow is Groton, which is a town of about 40,000, almost midway between the bad guys up in Boston and the good guys down in New York City. I'm a Yankees fan by trade, so it's really rough living up here again since they gave that series away to the Red Sox, who of course are now the champs. But I think we're 27-6 now, so I can still rave about being a Yankees fan. But this is where we're at. New England is pretty typical. You can go from one state to the next, and what I'm going to talk about tonight is pretty much the same. The technology doesn't vary much. If you were in California, you would probably have some different perspectives on how the wastewater is treated, because they do take a lot of extra steps because they ultimately are so short of water in some areas that they're looking at reusing the water that's left over as well as managing better the solids. Here we're not water restricted, so typically we want to clean it as well as we can, and then we just discharge it back into the environment. Our plant that I work at, we're permitted under the National Pollution Discharge Elimination System, or NPDES, by the state of Connecticut, which is one of the 48 states where the EPA has pushed down permitting requirements. One of the other two is Massachusetts, and I forget what the other one is. The EPA still gives them their permits. Our permitted design is 7.5 million gallons per day. We are actually around 3.0 million gallons per day, so that's the liquid that comes in the front door. Less goes out the back door because we take solids out. We process both liquids and solids. Solids, everything left over is basically called sludge. We use a BNR media. We'll talk a little bit more about that, but that's how we remove the nitrogen. Our town itself has 136 miles of collection system piping. And on an average year, we average about 1.1 billion gallons treated for the year, which is just about what Boston does in a day. So we're big for a small town in Connecticut, but small compared to any major city. We have separate sanitary and stormwater systems. I'm going to address a little bit about that later, but it is an important function. Older cities and communities typically have combined systems, which you cannot do today. There's a lot of money being spent separating them because anytime we have a rain event, if you are one of those combined systems, typically what happens is the rain overwhelms the sanitary system. It's all in the same pipe and it gets discharged back into the environment untreated. So you may have seen some of the cities are drilling those giant tunnels below the cities to pump it all into there and then treat it when they have time. That's one of the methods. Or just going back through and disconnecting the pipes from one another. So that is a key environmental issue right now. Just an aerial view of our plant. Sort of a typical, we'll talk about the treatment process here, as well as a little bit later. But just to give you a sense, water comes in underground and gets basically pumped up the hill and goes through treatment here and then back down around. We use gravity and then we pump it back out into the environment. This is a fairly typical design where we use primary treatment, secondary clarification, disinfectant. And as I said, we'll talk about that a little more in depth. But ultimately, what we're trying to do is to get rid of fecal waste, urea, and ammonia, and all these critters. So why do we treat wastewater? Well, obviously the ammonias and the carbon byproducts that are still left are not necessarily a problem other than what they can do as a food source or a fertilizer. What we're really concerned about are all those pathogens that live in the wastewater. Every wastewater employee that works for us and typically in the industry has all the hepatitis shots because that's a pretty virulent and long-living virus that remains in the water. But we also have to be concerned about some of the other critters. So from top left is Cryptosporidium, top right is Giardia, and then on the bottom left is E. coli, and then one of my favorites and one of the ones that when I speak with the middle school kids, they always love to hear about, bottom right there is the tapeworm, everybody's good friend. And of course, for scale on the bottom there is a ruler, and that's a 1 foot or 12-inch ruler. And when you tell the students that your typical adult intestine's 26 feet long, and that's the typical adult intestine tapeworm, it really starts to raise some questions about when you go to the lake or to the pond or swim in the river, swallowing that little bit of water that you're swimming. So this is why we're treating it, so we're not ingesting any of these friends into our systems. So the basic process flow really quickly for wastewater coming into the plant, as it goes through the collection system in our town, as mentioned, it's 136 miles of sewer pipe and intermediate pump stations, which, as I mentioned, we're trying to use gravity to get the water as far along the system as possible because it doesn't require any energy. But when you get to the bottom of the hill and you have to get over to the next hill, then we use pump stations to get over the top. Depending on where you live, they're pretty nondescript small buildings. They just look like a little square building, side of the road typically. You might think it's an electric or a phone building. Not much to them from the outside. And all that's doing is helping to convey the wastewater to the next part of the process. When it comes into the plant, what we do with it typically is it goes through the headworks, and that's where we remove all the parts of, or all the contents of the water that can't be treated. Sand, grit, eggshells, coffee grounds, plastics, wipes, anything that really isn't just biological and ground up. We take that out, that gets disposed of in the dumpster, and then the remaining liquid and those items dissolved or entrained in the liquid can be treated. It goes first in primary clarification, which is basically just a giant settling basin. It sits in there for 4 to 6 hours. The solids sink to the bottom. and then the nutrient-rich liquid flows to the top, and we process that through secondary treatment. And each of these steps along the way, you'll see that we're taking out solids, and they get processed separately. Secondary treatment is typically where we take care of removing the nutrients, including nitrogen, and some places phosphorus if you discharge into fresh water. From there it goes into another clarification stage where it's just allowed to settle one more time and look pretty. And we pull off the solids there. And then some plants, depending on where they're being discharged to or what they want to do with their remaining effluent, may go through tertiary treatment. That may be RO filters, if it's going back into drinking water. It may remove other chemicals, maybe phosphorus, depending on where it's discharging to. And then, of course, the last stage of the liquid treatment is disinfection. Typically, when I talk to the students, I ask them, how would we treat the water so that we killed everything in it? Because not everything is dead when it goes out the back gate of the plant. And that's pretty typical. So we'll disinfect either with basically bleach, sodium hypochlorite, 15% solution. We use about 100 gallons per day for our 3 million gallons to give you a sense of the ratio. Some plants are using UV disinfection, but really what that does is kills about 95% of the pathogens, and the remaining 5% approximately have been deactivated such that they can't reproduce. So there are still some living organisms in there, but their ability to reproduce or cause any type of health issue has been eliminated. And just quickly to finish up mentioning those biosolids, those are collected and used in a variety of different ways, again, depending upon where you live. Connecticut does not have a comprehensive biosolids program right now. So we are required to, you could either landfill it, which nobody does anymore because the landfills are closed, or in our case, we dewater it to the extent possible, and then we ship it out and it is incinerated. We are doing an upgrade right now to further reduce the solid or the water content and increase the solids percentage. Because right now, it's, in the process we use, it's not atypical to send out the biosolids at only 8% solid, which actually doesn't flow very well through a pump. It seems more thicker than you might, or viscous as you would expect, but it's still 90+% water. So burning a lot of water is very expensive and not very efficient. Some states do allow composting where you could compost it. You could take the methane off, reuse the methane. You could also use the remaining composted product as a soil amendment, which is an unusual. It's not really a fertilizer because most of the useful products have been removed, but as a soil amendment to help you regulate water content and whatnot, it's actually very good. So BNR, biological nutrient removal, we are very concerned with removing nitrogen from our process. We discharge into Long Island Sound, and fortunately we are at the eastern end where we have plenty of intertidal flushing, and we don't have any particularly narrow coves, areas of low water exchange. When you get closer to New York City on the western end of the Sound and other areas where you have a high population content, the concern becomes introducing that nitrogen into a small waterway where it quickly causes an algal bloom, which as the algae dies, it sinks to the bottom. As it decomposes, it sucks the oxygen out of the water, and then everything that's, all the living organisms there are in a hypoxic environment, and of course they can't live. So that's the biggest concern with introduction of nitrogen. So about 150 years ago, it was determined that the same bacteria in the soil, the Nitrobacter nitrosomonas that cause the nitrogen removal from soil, or the nitrogen cycle, could also be introduced into a water environment, and they're introduced in the wastewater. And we use these beneficial bacteria to help us remove the nitrogen. Of course, the nitrogen is introduced in urea, which becomes ammonia typically in the pipes. And by the time it gets to the plant, it's almost entirely ammonia. And then becomes ammonium, then becomes ammonia. And then we use our two different forms of bacteria in different parts of the stage with different quantities of oxygen to convert the ammonia ultimately to nitrate. And then other bacteria can use the nitrate. The facultative bacteria can use the nitrate during respiration. And ultimately, it off-gasses nitrogen as N2, which, as most people know, nitrogen's 70% or more of the atmosphere, the most abundant gas in the atmosphere. So the little bit of nitrogen we remove to the atmosphere is not a problem, much better than having it in the waterway. A little bit of CO2 and definitely H2O and OH. But if you're interested, there's the chemical reaction for you. Just the ultimate goal is to get nitrogen in other forms into a gaseous form where it can just naturally off-gas from the plant itself. So some of the issues that Jen asked me to talk about germane to today, just overall. Some of the things are just process. A big thing you may have heard about, depending where you're at, and if you have a commercial or municipal sewer system, are the flushables. Nitrogen and phosphorus, we talked a little bit about already. Certainly security concerns from the Homeland Security perspective. Resiliency is big on everybody's mind, particularly those of us at sea level. And the next generation contaminants are going to be something that we all need to be aware of. So just moving through these. I just finished doing my capital improvement budget for next year. And each year we're looking at ways of not only maintaining the infrastructure we already have, but trying to do some improvements to the processes to either make it less expensive or ideally to remove more of the pollutants already in there. Is zero pollutant discharge feasible or practical? It's really not at this point in time. You could probably do it, but it would cost far too much to make it practical. So we are trying to balance it to the extent that we can without driving the ratepayers crazy. That's the real issue, is what are you willing to pay? Some studies have been done that said the average household, you should keep your wastewater, your sewer treatment bills below 2% of the median income of that community to be affordable. So right now I'm at 0.75 for our community, and that seems to be about where the policymakers are happy with their rates. So although we could probably do more with more money, it's always a balance between what we want to do and what the public is willing to pay for. Obviously sustainability, less energy. An interesting aspect, this is both for the drinking water and for us, is the prevalence now of low water flow fixtures. So low water showers, and those related issues, because typically we've been an industry, as has been the drinking water industry, that relies on consumption. We charge by the amount that's processed or taken out of the faucet. So as that's been reduced, the infrastructure, as far as the number of pipes and the extent of it and the equipment in use, that stayed relatively constant or has grown as development has grown. But the consumption has gone down. So we're actually at the point now where the rates that in the past have been adequate are no longer adequate. And people are starting to question, well, why does it cost so much more for water? And part of that answer is because we're using less of it and we still have to pay for the same amount of infrastructure. So that's an interesting battle that's being waged right now. And one of the counter aspects of using less and using it more prudently. And of course, wastewater and drinking water, there's a lot of the human nature, human behavior. You know, I want my 30-minute shower at 180 degrees or 140 degrees, whatever it is. You know, I don't want to save water, or I do want to save water. Nobody wants the low flow, low flow toilets. So changing behavior to make those reductions a little more practical is going to be something that, education is going to be a major part of. And that's one of the reasons I enjoy going into the schools. In Connecticut, the water resources, drinking, stormwater, precipitation, wastewater, all that is part of the 6th grade curriculum. So it's the perfect time to go in and talk to the students. And they like to go home and take their little witticisms they've learned during the day and tell mom and dad and their sisters about all the great things they've learned about poop that day. So it helps, public awareness. One of the questions that we debate periodically as well is whether one form of pollution is better than another. And if we think back just a couple minutes ago talking about incinerating biosolids instead of having a comprehensive reuse policy, I am arguing for biosolids reuse, as are many people in Connecticut and New England now, particularly since we have to send them to an incinerator, and the Clean Air Act requirements have changed significantly so that the number of incinerators has decreased, as well as coincidentally, obviously, the concern about discharging carbon into the atmosphere has increased. So if there's a better way to use it that has less of an impact, we should be looking at which type of pollution we're creating and which is actually the lesser of two evils. And again, consumer costs, which I think we've just addressed. So flushable versus non-flushables. Flushable wipes aren't. You can flush a lot of things down a toilet, and that's basically anything that'll fit down it. But there's really only 3 things that should go down the toilet, and that 2 of those come out of us, and the 3rd is toilet paper. Anything else that goes down the drain can potentially clog the system. If you have heard anything in the news, particularly from the bigger cities, New York City in particular has a very aggressive program to stop the use and flushing of wipes down the drain. There are some that technically are flushable, but most people don't take the time to look at the product packaging to figure out which ones they can or can't. So when I talk to a group, I say there's only 3 things that should go down the drain, and anything else should go into a trash bag. It's just easier that way. Other things that should not go down the drain. Now, microbeads, of course, the Obama administration prohibited their use. They are still left over in some of the products that are already on the market. We all know the issues right now with the plastics in the environment. The floating mass in the Pacific and the similar one in the Atlantic that just doesn't seem to get as much airtime. Fats, oils, and grease. When I grew up on a septic tank, we were always told never pour hot cooking oil down the drain because it would clog the drain, and it's equally true for a large municipal system. I have a picture coming up of one of the side effects of that. And then, of course, the drain is not the disposal of choice for everything else that you just don't want to take care of by taking to the dump, the transfer station, hazardous waste day, or wherever you're supposed to dispose of it in your own communities. We do occasionally see significant sudden changes in the plant that are indicative of somebody dumping large quantities of chemicals down the drain, because we are ultimately a biological reactor. And if you put something in there that's going to kill bacteria, you can see very quickly the side effects. We have not lost the entire treatment train since I've been there, but in the past they have. And when that's happened, you basically have to let the system settle back out and then go to the nearest adjacent plant and borrow some of their product to reseed your own. So please do not send anything down the drain that's not supposed to, because you could wind up with these large fatbergs. So that is just a large mass of congealed cooking oil, fats, grease, solids, other things that shouldn't be disposed of. If you look back through the news, every year or 2, you hear about the big fatbergs being pulled out of the sewers in London. I'm not sure what it is. Maybe it's all the fish and chips that causes all the extra large fatbergs there. But the older systems, they do seem to accumulate a lot. We have a very aggressive program in our town, as do most of the communities in Connecticut, and I can't really speak beyond that, where we go to all of the cooking establishments that are qualified based on their size and what they produce. And we ensure that they either have a grease interceptor outside, a passive interceptor, or they have an active system, a grease trap inside. We go to make sure they're maintaining it, because we really don't want one of these clogging up our sewer lines. Nitrogen, as I already mentioned, is a large issue for us. We have to remove of it. We discharge into the marine environment. It's a fertilizer, as I said. It makes the algae bloom. The algae will ultimately, first of all, eliminate the ability of sunlight from reaching the bottom of the embayments. And of course, eelgrass is a concern for us. So no sunlight, no eelgrass. As it dies, it sinks down and settles on top of everything on the bottom, which is another source of the problem. And then, of course, as it decays and decomposes, it sucks out the remaining oxygen. So you can have large areas that are almost entirely anaerobic, or if not, at least very hypoxic, where nothing can live. So it would be nice if we could ultimately get to zero nitrogen discharge. One of the things that holds us back is the process of using DNR relies on the bacteria to do the work. Now, the bacteria need other things in the treatment process to come through. In particular, they need a large carbon source. For us and most plants, it's just whatever in the poop that hasn't been already decomposed. But that gets used up actually quite quickly. That's BOD, biological oxygen demand. That gets used up pretty quickly. So a lot of the plants that have very strict nitrogen discharge requirements actually have to add additional product to it. So glucose, sucrose, acetic acid, anything that can be digested by the bacteria so that they can release the nitrogen. So in many cases, you're adding an additional cost for a very low additional rate of return. And then just quickly to mention point sources versus non-point sources. There's a great deal of nitrogen taking out of the water by the treatment plants, but probably more entering the water by fertilizers, waterfowl, any number of things that just is trained in runoff. So until that part of the equation is really captured and resolved, you can't put all of the effort on the backs of the wastewater treatment facilities. But we do our part. Phosphorus is very similar, except it's confined mostly to fresh water. And I would only mention this, that it's a little more difficult process to remove it. And it's a battle right now between the drinking water communities and the wastewater communities, because the drinking water communities add phosphorus into the water to help protect their systems from corrosion, scaling, and other issues. And then, of course, that's added to what the treatment plant or the wastewater treatment plants have to remove. So it's this back and forth battle of who should be responsible for those costs. And it hasn't been resolved yet. Also, if you have to remove nitrogen or phosphorus and nitrogen, they are sort of incompatible. So you can usually do very well on one, but not the other. So they're also battling with that right now. As I mentioned, we are lucky. Our plant, we discharge right into the estuary, so we don't have to worry about phosphorus. It's a freshwater impact only. Okay, so security for the Homeland Security folks. If there's an event or concern of an event occurring, and you have a treatment plant, what do you really need to be worried about? So chemicals, that's really the big issue from a security perspective. We do not use chlorine gas. There are some large plants that actually still use chlorine gas. They get it on via different size cylinders. They could also get an entire railroad train load. So sometimes where you see the incidents with the chlorine container on a train, that's potentially where it was bound for. The chlorine's used to create the disinfectant, which ultimately kills the pathogens. Many plants have switched over to a bleach like we have, 15%, 13% in liquid form. It's much safer to deal with. You can't turn it into an explosive. You don't have to worry about it being a gas unless, unfortunately, people start mixing things together. But even so, we wouldn't have enough of the other product on hand to create enough gas to impact more than just a couple yards radius. We do have strong oxidizers also on hand. We use potassium permanganate. And what we do with those are add that into the waste stream at various critical points as a deodorant or a deodorizer. The source of most of sewer odors are caused by the bacteria respiration in the absence of oxygen. So when oxygen is depleted, they use sulfur, and they start to release hydrogen sulfide, which provides that rotten egg smell that we're all familiar with, or the low tide smell. And living in a community that's on the waterfront in May, when the tourists start coming back, we get a lot of calls about our leaky sewage system down by the beach. And typically what that is just low tide, because Parks and Rec likes to remove the extra seaweed during the summer, but they've left it all there all winter. And the first warm day, it likes to start off gassing. So that hydrogen sulfide smell, we use strong oxidizers, we introduce it. The oxidizers, as you probably know, by themselves aren't a problem. It's when you have a fuel source and a flame that becomes an issue. So the real concern there is someone coming in and stealing your oxidizer for use somewhere else. And we have some stronger caustic chemicals. We keep high concentration sodium hydroxide or lye on hand to help with pH. I don't see anyone using that particularly in a bad way, just because it's, I think, low effect and you need a large quantity of it. And of course, any industrial facility has fuel. And again, once you'd have to steal it. But in general, then would just be general security would be system protection. A lot of plants now are automated. The pump stations are automated. There could be opportunities for vandalism, and that would result in the release of wastewater into the environment. Again, it's considered non-hazardous. It's not a hazardous material. Obviously, there are concerns about health issues related to it, but it's not a significant hazardous waste response. But just some of the issues related to security for us. I was asked to talk about resiliency as well, particularly in the era of increasing storms and changes in sea level rise. And also, if you follow the infrastructure scorecard for the country at large, I believe the water resources community got a C- on the report card, which is better than several of the other communities, but still could be better. So we have aging infrastructure. We're always battling that. And of course, we use gravity to get our water to where it needs to be. And then we put our treatment plants at a low level so it can discharge right into the river or into the sea. So everything's at or close to sea level, or at least in the floodplain. We do have outfalls that are entirely underwater. And then our linear infrastructure, which basically our lines, our manholes, they can easily become submerged. And if you have a manhole submerged that's not watertight, it becomes basically a fruitless effort in trying to pump the ocean back into the ocean. So this is our plant. This was done as a hurricane surge analysis in 2012. The yellow is the maximum water level rise. And you can see that we get pretty well surrounded by the water at that flood level, which is plus 18 above mean high water. It doesn't look too bad because you might say, well, at least the plant's above water at every point, or maybe only a couple inches deep. The issue really with wastewater infrastructure in our plant is you can think of it as an iceberg where only 25 to 30% of the operations are above ground. The rest of it is all underground. So if you have an entry point into the tunnels or any of the subsurface infrastructure, then you have a big concern about flooding. We are going through a major project right now to remove our electrical distribution, which was for some reason installed in the basement when the plant was originally built, which is at elevation 0, and put it at elevation 20 above ground so that we're out of the flood complaint or out of the flood risk areas. We are fortunate though that we are at that high elevation. because some of our pump stations aren't. So this is one of our small pump stations in a residential community called Groton Long Point, which is the beachfront part of town. There's a little pump station, like I said, they're pretty nondescript. This one was flooded out and about halfway up the door by the storm. When they opened the door to get in there after the fact, they claimed that the fish were swimming out as the door was being opened. I don't doubt it. You can see in the upper right slide, the water in the background gives you a sense that we're really only a couple inches to a foot above mean high water on any given day. So any type of storm surge quickly inundates the facility. The picture lower left gives you a sense of what this particular pump station looks like. So that is looking down into what would look to most people like a missile silo. It's just a small turret. That's usually watertight, but unfortunately it wasn't watertight enough for the time it was submerged. So the pumps down below there were damaged by the water. We had to pump the whole thing out, and that system was offline for a couple of days. And then just on the bottom right slide is a pump station in downtown Mystic, which is a large tourist area. And that again is right on the waterfront. And you can see the debris on the sidewalk was what was left behind from the flooding. So we do have a concern with most of our pump stations and flooding. So resiliency be concerned, and we are working on that right now. And just for perspective, I know the operator that runs the plant up in Warwick in 2010, they had major flooding during March from rainstorms. They had about 22 inches in 10 hours worth of total time, and it totally flooded out the treatment plant. So they basically lost the entire plant for several months. Since then, they built a berm around it, a little Dutch boy dike, as they call it up there. And if it were to flood out, or if the river were to flood out in the future, at least the infrastructure would be protected. And the last concern we have right now are the next generation of contaminants. So as we finally get a handle on dealing with nitrogen and phosphorus, what we're going to have to look at now are metals in the water. Heavy metals, cadmiums and whatnot. Those are probably going to be the next area of concern, as well as pharmaceuticals. I hope everybody lives in a town where they have some way of disposing of their former pharmaceuticals properly. Our police station takes them. I think the drugstores take them now. The concern with most of those products is there's no particular treatment process at the wastewater treatment facilities designed to remove pharmaceuticals. Large concern, of course, is estrogen from birth control pills, some of the other hormone-based therapies and their impact on the aquatic fauna. That's definitely a concern. And then we don't know what's coming next. It's like anything. What's the next product that causes cancer? What are we going to have to get rid of next? Right now, I forget the proper term, but Teflon cooking pans. The Teflon surface wears off. It goes down the drain. That's another thing we have to be concerned of. I think those are PFOAs, perfluorinated. I forget the rest of it. But there's always some new contaminant that we have to be concerned of. So ultimately, we'd like people to always dispose of the right things, or things in the right places. So looking forward for us, climate change is going to be the biggest challenge. We know it already. Our infrastructure's already been impacted by smaller storms. There's a lot of money going into infrastructure and resiliency. The major universities in the Northeast, probably in the rest of the country, are researching, doing studies. The big solution is going to be in the form of money to either retain the infrastructure or to have a larger, broader policy concern and discussion about retreat or other solutions. And ultimately, consumers are going to need to adapt. And I think with that, I am done. So I guess it's open to questions, or however you typically run your webinars, Jen.
Well, thank you very much. If anyone has a question, they can either unmute their mic or they can type it into the chat box and I can just read them off.
Chris, this is Gene. That was great. I learned a lot. I really appreciate your clear explanations of the whole system. You're a pro at doing this, not just managing your wastewater system, but also explaining it. So thank you. I probably am at a sixth grade level on this thing. So thanks. That really was good. So I have one silly question and then a more serious question. So the silly question is, so you started talking about the separation of sanitary and stormwater runoff. So in a lot of places, including here in State College, you'll see signs over this, or not signs, but little embedded symbols over the sewer, street sewers, that says that this drains to such and such a creek or reservoir or to the ocean or whatever.
Yep.
I always thought that were rather silly because I thought everybody knew that. Is that a promotional effort, or is that really effective at keeping things out of the stormwater runoff?
I'm not sure if anyone's done a real study on how effective that is, but I think it at least serves as a reminder for those few people that maybe were going to pour their, they changed the oil in their driveway and decided to not pour it down the drain. I'm not really sure what the efficacy has been shown, but we have the same thing up here. Drains to to Narragansett Bay or drains to Connecticut River or whatnot. So I don't know the real answer to that.
Okay. So anyway, can you talk a little bit about how your town, where your wastewater treatment plant is, and its emergency response plan, and how you participate in that sort of planning activity and exercises and such?
So we have, there's a couple layers to that. So our town itself, we have, an incident management branch that's basically staffed by the police department for incidents. Obviously, any incidents in the community are, care and protection of the citizens first, and then infrastructure second. During the last major event, which Irene or Sandy, I forget which one was which, both preceded my time here. Most of the community was overwhelmed dealing with trees being down. So a lot of the resources went to basically getting the roads back up and running. We are very fortunate that we have redundancy for the wastewater system, both in extra power, we have 2 of each at the plant or more. So when we had the last issue, the plant itself remained in operation. Most of the pump stations were unaffected. So it was only a couple of the real low-lying ones. And in those cases, we responded once the floods went down as best we could. And while that was going on and we couldn't do anything, it's all hands on deck helping the rest of the town. So I don't know if that really helped you too much. Now, or answer your question, Connecticut itself, we're part of the Northeast or the East-Northeast region of the state for RESF 3 for emergency response. So that's a conglomeration of the communities and help one another as needed, depending on what the issue is, whether it's major snow in the winter or hurricanes in the summer. So we have quite the variety of things that do occur.
Mm-hmm. So, and I guess another question is, so what sort of security do you have at your plant? You mentioned some of these items about that need security, chlorine gas, or you said you don't use the chlorine gas though, but
yeah, we don't have, we have the oxidizers. Most of our stuff is stored inside. It's locked up. We are one of the plants that we do have a 24-hour presence at the plant itself, as well as security cameras that can be accessed remotely by the police. So we have a 24-hour presence. Some plants do not, so they rely on remote monitoring and alarms, as well as our pump stations. We have remote alarms if someone, just improper access alarms. So although we may not have someone at all those locations, if there's an issue, we do get notified automatically so we can respond. And that's pretty typical.
Okay, great. Good. So when was the last time you saw an alligator in your system?
None, but I talked to the kids last week. I told them that we had a big tank of their goldfish that we keep.
Okay, very good. Thank you. Thanks.
Does anybody else have any questions? I don't see anything in the chat box, and I don't see any hands raised. So if nobody has anything, last chance. All right, well, I guess not. So Chris, thank you so much for coming and talking. This was especially helpful after we saw what happened down in Florence. So thank you so much for coming.